section 13.1, which is finding sample space and probabilities. If you flip a coin and roll a number cube, and this is a six-sided number cube, how many possible outcomes are in the sample space, and list the possible outcomes. You have to list the outcomes first in order to know how many possible outcomes there are. So we are going to start out with either heads or tails on our coin, and we will have six different outcomes for our number cube. All six of those can happen either with the heads or with the tails. And what we'll do is we will list each of these: heads and ones, heads and twos, heads and three, heads and four, heads and five, heads six, or tails one, tails two, tails three, tails four, tails five, tails six. There are 12 different outcomes, and we have listed the sample space here, taking care of both parts, listing the outcomes and how many there are, as well as listing the total sample space. On this next part, you're going to flip two coins and roll a number cube. Again, this is going to be a six-sided number cube. It probably would be easiest for us to first write down the numbers that are on the number cube, and then we start thinking about the coins. The coins, I could have heads and heads, I could have heads and tails and heads, or tails and tails. And that is going to be true for each one of these, so that we can have heads and heads on each one, heads and tails on each one, tails and heads on each one, or tails and tails on each one. And with our sample spaces, then we're going to make sure that we put our numbers in front of them as well. Just a nice, easy way to organize them. Now, when we look at this, we got 6 times 4. We have 24 outcomes. So we have to know how many possible outcomes there are. There are 24. And list the possible outcomes. Right here is our sample space. We have listed all of them. Probability of an event is the measure of the likelihood or the chance that that event will happen. Probability is a number from 0 to 1, and it can be expressed as a decimal, a fraction, or a percent. For the most part, we'll be doing fractions. I do have the decimals up here so that you can see how it's related to the percentages as well. You know, it's not likely, it's not going to happen at all. That's a probability of 0. It's impossible to happen. If it's absolutely certain to happen, that's a probability of 1. The probability of 1/2 means that it's equally likely to happen as not happen. And then you can see, as we have our numbers here, of 0.25 is kind of unlikely, and 0.75 is more likely to happen. Theoretical probability is the number of favorable outcomes divided by the total number of outcomes. Theoretical probability is what is supposed to happen. Okay, this is what is supposed to happen. Theoretically, this should happen. So we're going to do a problem here where we have t-shirts, red and green, that have emblems on them, gold and silver. If you take a look at the 4 numbers that I have in the chart, I've got 10, 8, 6, and 6. We can actually add those all up and come up with a total number of 30 t-shirts altogether that there are green with a gold emblem, green with a silver, red with a gold, and red with a silver. So 30 different t-shirts. We want the probability of a red t-shirt. Well, if you look here, I've got 6 with a gold emblem and 6 with a silver. So there are 12 ways that I can have a red t-shirt out of a total 30 different t-shirts that are totally possible. Please put the fraction in lowest terms, divide them both by a common factor. The largest common factor would be awesome. That happens to be 6, so we'll come up with 2/5. We will have our answers as a fraction if possible. You guys know that that's actually 0.4 as a decimal. It's 40% as a percentage, but a lot of the times we'll just be working with our fractions. So be able to do any one of those 3. Let's also find the probability of a gold emblem. Well, the gold emblem, there are 10 of them that are green and 6 that are red. So it's actually 16 out of the 30 possible shirts. And once again, divide the numerator and the denominator by the common factor, the biggest one, which in this case is a 2. So I have 8/15. And we'll leave that nice fraction there because I think that decimal is kind of a wicked decimal. So we'll have 8/15 as our probability. If you toss a coin and roll a number cube, again, we're going to use a 6-sided number cube. What is the probability that the coin shows tails and the number cube shows 4? Well, we have that number cube, 1, 2, 3, 4, 5, and 6. And the coin that we are tossing could be heads on each of these. Or when we roll that number cube and toss that coin, the coin could show up to be tails. When we look at our sample space, we see that we have a total of 12 possible outcomes. So we'll put the 12 in the denominator. How many times does the number cube show a 4 and the coin shows tails? Well, there's only one, 4 and a tails. So we're going to put a 1 in our numerator. The probability of a tails and a 4 is going to be 1/12. Experimental probability. Experimental probability is the number of successes over the number of trials, meaning what actually happened in an experiment. Okay, this is what turned out when you did an experiment. So we're going to look at spinning a spinner. And in the spinner, they got red 5 times, green 9 times, blue 3 times, and yellow 3 times. They are wondering for which color is the experimental probability of stopping on the color the same as the theoretical probability. And we know the spinner was spun 20 times. First thing that we're going to look at is the experimental probability. The experimental probability is the number of times it happened over the number of times that we tried. So 5/20. Next one's 9/20. Then we had 3/20 and 3/20 for the yellow as well. Theoretical probability. Well, we have to determine what that is in order to see which one of these is closest to the theoretical probability. Each one of those colors up there is an equal space. And there are 4 colors. And so when we're talking about getting a red, there's only one way to get a red out of 4 possible colors up there. And that is true for the green, as well as the blue, as well as the yellow. All right, theoretical probability, experimental probability. When we look at the numbers on these, we know that 1/4 is equal to 0.25. 5/20 is also equal to 0.25. So we should already look and say, hey, the red from experimental was the exact same as the theoretical. Whereas the green was at 0.45, the blue was at 0.15, and the yellow was also at 0.15. In other words, 25% of the time it came up red in the experiment, 45% of the time it came up green in the experiment, and 15% of the time it came up blue, and the other 15% of the time it came up yellow in the experiment. Whereas it should have only come up 25% of the time each time. That's theoretically what should have happened, but experimentally it did not. I would like you to work on page 846. The numbers are listed. Work on those. Stop the video right now and work on them, and the answers will be on the next screen here when you start the video again. Now that you've restarted the video, here are the answers for you. If you have questions over them, please come in and see me. Have a great day.